Hello everyone, welcome back to my channel Fusiboards. In the last video we have seen how we implement RRT star to make a path for our robot, and in this video we'll see how we fit a trajectory over the path which is made by RRT star, and I will also help you to deep dive into how the complete algorithm works, like the full pipeline. If I got a point in the Cartesian space, how I make a RRT star, and then how to make the path continuous and then put a trajectory over it so that the path in the Cartesian space looks smooth. So on my screen you can see there is a little twin of the same robot I have here, and it replicates the same motion of my hardware as I have already shown you in my previous video. So before deep diving into the technical code and everything, let's first see how it actually works, the trapezoidal profile. And I will also let you see the graph, whether it will following that profile in the velocity space or not. So let's start. This is a small GUI I have made so as to make it easy for me to control the robot. So let's suppose I am giving a point here as 0.05 and here 0.12, and I am giving a time of 3 seconds, and I also have graphs here so that we can verify whether they are following it or not. So let's publish the command. Now have you seen that it followed a trapezoidal profile? Now let's suppose let it go to the home. Again you can see on my screen that it followed a trapezoidal profile and the motion was smooth. Even if I go to the joint space and try to move a single joint, so for suppose I am moving this joint by 30 degrees, let's see how it works. See, now for each joint also it will follow a trapezoidal profile. Okay, so this is to demonstrate that it works basically. Now we'll deep dive into how the coding and the explanation part of it will be. Let's go. Now on my screen on the left side you can see that there is a trajectory sampler, and on right side the manipulator model node is the main node which is having all the things, and on the left side we have the sampler which is actually sampling the trajectory, like any kind of trajectory. And then I have a trapezoidal time scaling, so we can have quintic time scaling, we can have trapezoidal time scaling, cubic time scaling, you can use anything what you want. This is the basic trapezoid, like you know that there are three. First I would like to show you how it works visually, then we'll deep dive into the code. Now on my screen I will show you how it works. So basically I have this path. Now I will try to fit a trapezoid over this point, see how it works. So basically there are two things. At each and every iteration I am evaluating a time law, and then I am evaluating a path. Okay, so you can see time path, and with the help of that I am basically planning a trapezoid over my velocity space over that path. So you can see the left hand side, you can see that this the animation I showed you is made from this code only. So this basically contains two things, one is a time law, one is a path. So time law is basically making sure that there is a path parameter that is making a trapezoid, and then from that trapezoid we are calculating a joint angle, that is q. So I am basically fitting a trapezoid over my path parameter s, and then I am making sure that I am multiplying with that path parameter so that corresponding to that path parameter I have the joint angles. So in path space I am basically following the path that is already made by RRT star, and then in my velocity space I am making sure that there is a trapezoidal velocity profile. Now how this entire pipeline works basically. So for that I need to show you animation which I made like for basically explaining you how this entire pipeline works, right? On my screen you can see how this entire joint motion planning pipeline works. So basically there are these number of steps in it. So there is a current state and then there is a goal. So from that I will find a global RRT star that will basically calculate these points in here. Then I will calculate the waypoint, I will make a continuous path over it, and then I will do the trapezoidal scaling over it, and at the end I will do the execution. So you can see on my screen how this entire pipeline works, right? So this is a small video to explain you how I fit the trapezoid over my path which I made from RRT star in my last video. If you want a detailed video on how this complete pipeline works, let me know in the comment section. because I have already made a video on how RRT star works, then how I make the part continuous, then how I fit a trapezoid over it, how these both varies in joint space as well as Cartesian space. So that's it from my side for this video. This is a shorter video. If you think that my content is good, please subscribe to my channel and comment down your thoughts. How can I improve and what should I add more in the videos? And comment the topics on which you want the next video. Thank you. See you. Bye bye.